everybody, today we're going to be looking at solving quadratics by square root. Now, in order to use this method, your quadratic must be in the form of ax plus c is equal to 0. This is standard form of a quadratic, but you're missing the b value. Or your equation must be in the form of vertex form. This next one right here, the ax minus h squared plus k is equal to 0. This is vertex form of a quadratic. So the steps on trying to solve by square root is first you must get your x squared or your x minus h squared by itself. Once you've done that, then you have to take a square root on both sides. And after you take the square root on both sides, then you can write your answer, but don't forget to put this symbol in front. So this symbol represents a positive and a negative, and that's because your quadratics must have two solutions. Okay, so let's go ahead and let's take a look at a couple of examples here. So example number 1 says x squared is equal to 64. So we want to take a look, is the x squared isolated? Yes, there's nothing added or subtracted from it, and there's nothing multiplied to it. So we're moving on to step 2, which says we need to take the square root on both sides. So I'm going to take the square root of x squared and take the square root of 64. So once you take the square root of x squared, that just undoes itself. So the square root of x squared just leaves us with an x. And hopefully you're looking at 64 and noticing that it is a perfect square. And the square root of 64 is 8. However, when we are talking about solving by taking a square root, we need that symbol in front, plus and minus 8. So if you were to graph this quadratic, the two roots, your two solutions, your two x-intercepts, will cross the x-axis at a positive 8 and a negative 8. Okay, so let's move over to example number 2. So here we have this x squared is equal to 24. Our x squared in this case is also isolated. So then all we need to do is take a square root on both sides. Again, taking the square root of x squared leaves us with an x. And hopefully you notice that 24 is not a perfect square. So what we're going to do is we're going to come off to the side and see if we can simplify it. I am going to use the prime factorization method on what you learned in the previous lesson. So I'm going to come over here and I'm going to take 24 and I'm going to start dividing it by its prime numbers. Well, 24 is divisible by 2, which is going to give us a 12. I'm going to divide that number by 2. It's going to give me a 6. I can continue dividing by 2, which is going to leave me with a 3, and I can divide 3 by 3, which leaves me with a 1. So remember, by using this method, it takes the buddy system in order to come outside. So I have a pair of 2's. So a 2 is going to come outside, but not just a 2, it needs to be a positive and a negative 2. Then this 2 doesn't have a buddy, so it needs to stay underneath a radical, and this 3 doesn't have a buddy, so it needs to stay underneath the radical as well, and it's going to get multiplied to the 2 that's underneath there. So in this case, your two solutions are x equals positive and negative 2 square roots, and we're going to multiply that together. 2 times 3 is 6. So by doing this, you get a more exact answer of where your graph is crossing the x-axis. Okay, so let's go ahead and let's do a few more examples here. So example number 3, is your x squared isolated? Well, hopefully you're saying no, because there's a 3 that's being multiplied to it. So in order to get rid of the 3, we want to divide by 3 on both sides. So now, once we divide by 3, we're left with x squared is equal to 12 divided by 3 is 4. And then once your x squared is isolated, we're going to go ahead and we're going to take the square root on both sides. So the square root of x squared is our x. And hopefully you notice that 4 is a perfect square. And the square root of 4 is 2, but since we're solving, it is plus and minus 2. Again, graphing this, you would be able to see that your graph is going to cross the x-axis at a positive 2 and a negative 2. So let's go ahead and let's take a look at example 4. Okay, so is your x squared isolated? Well, absolutely not. We have a couple of numbers that we need to move over. The first number that we should move over is our 72. So we're going to come over here, we're going to subtract 72 on both sides. Okay, so now we have 2x squared is equal to negative 72. Well, now we need to get rid of the 2, so we're going to go ahead and we're going to divide by 2 on both sides. So once we divide by 2, we get x squared is equal to negative 36. So now that your x squared is isolated, now we can take the square root on both sides. Again, the square root of x squared just leaves us an x. Remember to put your positive and negative symbol. But now we're looking at the square root of a negative number. So going back to the previous lessons, we have learned that the square root of a negative 1, so we're going to write this up here, the square root of a negative 1 is equal to an I. So what we're going to do is we're going to separate these two numbers. We have negative 1 times a positive 36. And hopefully you recognize that 36 is a perfect square. And the square root of 36 is 6. And the square root of negative 1 is an I. So this means that your graph has two imaginary roots. So if you were to go back into a graphing calculator and graph 2x squared plus 72, you would see that your graph does not cross the x-axis at all. And so that's what the imaginary roots are telling you. Okay, I have a few more examples I'd like to go through with you. So let's take a look at number 5. Okay, so in order to isolate your x squared in this case, we're going to first subtract a 1. Okay, so that's going to leave us a negative x squared is equal to a negative 12. And then we need to get rid of that negative sign in front of the x squared, so we're going to divide by negative 1. So x squared is equal to a positive 12. So now we're at the point where our x squared is isolated and we can take a square root on both sides. So x is going to equal positive and negative. Again, 12 is not a perfect square, but maybe we can simplify it by using the previous lesson. So let's come off to the side and let's take our 12 and see if we can break this down into its prime factors. So 12 is an even number, so I'm going to divide it by 2, which gives me a 6. Divided by 2 gives me a 3. Divided by 3 gives me a 1. So I do have a pair of 2's, so that tells me the 2 can come outside. So plus and minus 2, and the 3 doesn't have a buddy, so he needs to stay underneath the radical. So your solutions for number 5 are plus or minus 2 square roots of 3. So let's go ahead and let's move over to number 6. Okay, so same thing, just kind of walking through the steps if you need these extra examples here. First step is to subtract the 1. So we're left with negative x squared is equal to negative 18. Divide by a negative 1. So x squared equals positive 18. Again, take a square root on both sides. recognizing that 18 is not a perfect square, so we're going to come over to the side and see if we can break this down into the prime factors. So 18 is divisible by 2, but we get a 9 out of that. So we have to divide 9 by a 3 to give us a 3. Divide by 3, we get a 1. So our buddy system here are these 3's. So we can say x equals plus or minus 3. And the 2, since it doesn't have a buddy, needs to stay underneath. So plus or minus 3, square roots of 2. Okay, so let's go ahead and take a look at number 7. In order to isolate this x squared, we would need to subtract the 9 first. So we would get 3x squared equals negative 9. Divide by 3. So x squared is equal to negative 3. Take a square root on both sides. So x is equal to plus or minus. Now in this case again, 3 is not a perfect square, but hopefully you recognize that 3 is a prime number, and we can't even simplify it. There is not a perfect square that goes into 3. But there is that negative 1 underneath the radical, and hopefully you're recognizing that negative 1 will come out as an I. So we'll take that negative 1 out, and it'll leave us the positive square root of 3 underneath. So here are your two imaginary roots, x equals plus or minus I, square roots of 3. Okay, so let's look at example 8. So in order to isolate this x squared, your first step is to move over the 5. So we're going to subtract 5 on both sides first. Do not be intimidated by this fraction of 1/3 x squared is equal to 2. Here's how you get rid of a fraction. Multiply both sides by its reciprocal. Multiply the other side by the reciprocal. This cancels out, leaving you with x squared is equal to, and then we're just going to multiply 2 times 3, and we're going to get a 6. So that is all you need to do, is multiply by a reciprocal to get rid of a fraction. So now to get rid of the x squared, we're going to take the square root on both sides. So we get x equals, we need our plus and minus. Again, 6 is not a perfect square. Can we simplify it? Well, let's come off to the side. 6 is divisible by 2, and we get a 3. So there is no buddy system, so both of those numbers would stay underneath the radical, just leaving us a square root of 6. And there are your two solutions for number 8. I do have 2 more examples, and those will be in vertex form. Okay, so our last 2 examples are written in vertex form of a quadratic. So notice that we have the quantity of x plus 2 being raised to the power of 2. So because that plus 2 is in parentheses, that's what we would need to isolate first. Okay, so if there's anything multiplied in front or maybe added or subtracted behind it, that's what we would need to move over. But in this case, that x plus 2 squared is already isolated, so we can go ahead and we can take a square root on both sides. So again, taking a square root of something that's squared is just undoing the process, and they cancel each other out. So all we have left is we can bring out one of these x plus 2's. Okay, so then on the right-hand side, we have the square root of 5. But again, you guys are solving, so it's not just a square root of 5, but it is plus or minus the square root of 5. Now we need to get x now by itself. So how do we get x by itself? Well, if there's a plus 2 by it, we just need to subtract 2. Okay, so now we're going to get that x is equal to, please do not combine these two numbers over here. I'm going to put my negative 2 first, plus or minus the square root of 5. And there are your two roots. So if you kind of wanted to separate them to see them, x equals a negative 2 plus the square root of 5. Again, you can't combine these, and x equals a negative 2 minus the square root of 5. Okay, last example, example number 10. Okay, so now again we need to isolate this x minus 4 that's being raised to the power of 2. Well, there's a 2 that's being multiplied in front of it. Do not distribute it throughout the parentheses. That is not what you need to do. Because it's being multiplied, we want to divide by 2 on both sides. So that leaves us with x minus 4 squared is equal to 16. Now once that quantity of x minus 4 squared is isolated, now we can take a square root on both sides. So again, the square root is removing the square, and so all you have left is an x minus 4. The square root of 16, remember we still need our plus and minus sign, and hopefully you're recognizing 16 is a perfect square. Square root of 16 is 4. Okay, in order to get x by itself, we need to add 4 to both sides. So we have x equals 4 plus or minus 4. Well, we can actually calculate these. We can calculate 4 plus 4, and we can calculate 4 minus 4. So 4 plus 4 is 8, and 4 minus 4 is 0. So this graph actually crosses the x-axis at 8 and at 0.